Hi everybody, this is the Math 31 applications review. This is question 10. Just before I started recording here, I was looking at this question trying to think if there was a shortcut way that I could go about doing this, but I really don't see it off the top of my head here. Here's how you want to handle this. Don't get thrown off by this. You want to be kind of lazy with this. An isosceles right triangle, this is what we're talking about, okay? Where this side and this side are identical. And so just for argument's sake here, let's call this x and x. Okay, it's an isosceles triangle, those have to be the same. Now what we're told here is that the area is decreasing, so dA by dt is decreasing, so negative 5 centimeters squared per second. We want to know at what rate is the hypotenuse changing. Okay, so let's put an h there. Now that's interesting because the formula for the area does not in fact include the hypotenuse. I would simply include the base and the height. So what's interesting about this problem is it kind of links two different aspects of this function together, or this triangle together, I should say. The area depends on x, but the hypotenuse also depends on this value of x here. We're going to see that in just a second. So first of all, let's just start with this. What this is meaning to me, okay, when I take a look at this, I know that the area calculation is going to be 1/2 the base times the height. Now because this is an isosceles triangle, those two are the same. Now when I take the derivative, and again I have to do this implicitly because I'm taking the derivative with respect to time, and there is no time in this expression here. There is an a and an x, and they are both implicit functions of time. So I take the derivative of a, which will be 1 times dA by dt, will equal 1/2. Okay, now I bring down the 2, so the 2 and the half will cancel, left with an x, times dx by dt. Okay, and I was told that we're trying to figure out what the rate at which the hypotenuse is changing when each of the other sides has a length of 10. So you are told here, I should have written this down initially, that each side is 10 centimeters. So the first thing that I'm going to do is I'm going to figure out what dx by dt is. I want to figure out how fast that side is changing. I know that the area is changing at -5, and I know that the x is 10. And so when you divide, you're going to get -1/2 is equal to dx by dt. Now that is not the hypotenuse. That's just the rate at which the side is changing. So how does that relate? Well, let's talk about the hypotenuse. Based on the triangle that I've drawn, okay, the Pythagorean theorem is going to tell me that x squared plus x squared is equal to h squared. Now this is just going to be 2x squared equals h squared. And now what I'm going to do here is I'm going to figure out the pieces. Now remember, what I'm looking for here, my goal is dH by dt. And I probably should have identified that back over here. What we're looking for is dH by dt. Don't know what that is. But now I can take the derivative of this expression, okay, implicitly again, because there's no time mentioned. This will become 4x dx by dt, which will equal 2h dH by dt. Now I'm looking for dH by dt, so I'm going to divide this over, so I'm going to get 2x over h dx by dt equals dH by dt. I'm so close. I know that dx by dt, sorry, I know that, initially I should say it like this, I know that x is 10. I know that dx by dt is going to be -1/2. What I don't know is h. I don't know h at that particular instant when the sides are each 10. But actually that's remarkably easy for me to calculate because this is going to be 100. Okay, this is 10, this is 10. So the Pythagorean theorem would say 10 squared or 100 plus 10 squared, 100. Okay, 200. So 100 plus 100 is equal to h squared. 200 equals h squared. So when I take the square root of that, I am going to get 10 root 2 is equal to h. So that information was not given to me directly. I just had to figure that out here. And that gives me 10 root 2. And I will simplify this on the other side here. Notice that the 10s will cancel. Actually, the 2's will cancel. I'm left with -1 over root 2. And I would say centimeters per second. Now, you might be required to rationalize that to get -2 root 2. centimeters per second.